All right, so a pleasant evening, everybody. Welcome to another session, another week. Can one of my students update me as to what we were on last week? I believe that we were doing algebra, yes? Was it algebra? Can we confirm? Yes, no, maybe so. I don't know.
Yes, the distributive law.
And that was last week, Monday, right?
Yes, sir.
All right. All right, let's just pick up from where we left off. Da 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 da. Whiteboard. Are you guys seeing my screen?
Yes, sir.
Somebody said they've been trying to log in for the last 20 minutes. That is insane. I started the class at 7:10. That is insane. Oh, they're using the old link. Give me a sec. Give me a second, guys. I tell this person to message before, So what you're doing now, you're sending me a message whilst I'm teaching. This is insane. Try. Give me a second, guys. Oh my lord. Mm-mm-mm. All right. So Farah, are you not in the class, Farah? Farah.
Her name is there.
Yeah, but I just see a message in the group at 7 o'clock. Oh, she probably is in the room, or she probably at work. So, all right, let's go. So I don't see anybody in the waiting room. I'm going to exit. I'm going to go. All right, that's it. All right, lovely. So let's see here. Monday. We titled it Monday. So we were doing it with distributive law, yes. Mm-hmm. All right. As you can see here, this is where we were. Lovely. We went through that whole process of foiling. All right. We went through that process of foiling and distributive law. Might we do a recap? So make it make sense? Talk to me now, guys. A recap is good to go, or you're all right?
Yes,
We don't need a recap. I didn't hear that.
Is it possible to get a recap?
Okay, sir. Okay.
Oh, it's always possible to get a recap. It's always good to do recap. All right, here we go. All right, so our recap. All right, so remember, right? Keynote en el futuro, in the future, if you see an expression that requires simplification and it involves brackets, please note that you use the term, which can be a single number, it can be a letter, or it can be a combination of a letter and a number, and you'll use whatever is on the outside of the parentheses, and not just what is on the outside, what immediately precedes the bracket, and you use whatever is on the outside that is immediately on the outside of the bracket to multiply what is on the inside of the parentheses. And we also have another distribution method that is called the binomial expansion, where we use the foiling method. So I'm going to do 2 examples for you here. All right. I'm going to try to do 2 examples that will encapsulate everything that we've done. Okay. So instruction will say simplify. So this is going to say x open bracket 2 minus y minus 4 open bracket 3x minus 2xy plus, I'm trying to use one example to bring out all that we've learned, plus 4x bracket 3 minus y. So you won't get a very long one like this, but this particular example will highlight what I'm talking about. All right. Now, if you look carefully here, you see that the first bracket, we are being required to use the x to distribute inside. So that's where we're using a term to distribute. For the second distribution, we are being asked to use a numerical value to distribute. So we're using the -4 to go inside the bracket. And for the third example, we are using not just a term and a number, but we're using a combination of both. So to distribute inside the bracket like that. So we're going to go ahead and do just that. So x times 2, x times y. Moving on, continuing. -4 times 3, -12, x, -4 multiplied by -2, that's going to be +8 xy. And if we proceed to the third parentheses, 4x times 3, that's going to be +12x. And then 4x times -y is -4xy. Now we can group like terms. We can put this x and this x and this x together. And then we can also go ahead then and put this xy, and this xy together. Now, some persons will rewrite the question so that it's better for them, while some person can just look at it and add it mentally. That's fine. Do it if that's what you like. I'm going to rewrite it. I'm going to put 2x here. I'm going to put my -12x here. And I'm going to put my +12x here. And then now I'm obviously going to go ahead and put my -xy, which is basically -1xy. Let me put that 1 there just in case. Plus 8xy minus 4xy. All right, now we're going to go ahead and add these together. 2 minus 12 is -10. And -10 plus 12 is going to give us 2x. All right, so those terms are alike. We can add those together and subtract them. For the next set of terms, this is over here. They're all xy's. So we can add or subtract them together. -1 plus 8 is 7. 7 minus 4 is going to give us 3. So that's going to be +3xy. So we have broken down the expression to the final answer of 2x plus 3xy. Everybody good to go?
Yes, sir.
Good. Now remember, we have some tricky examples that we don't want to ignore because they will pop up, not only in algebra, but they'll pop up in other areas as well. So here, take for example, you're asked once more to simplify 4x, oops, you're asked to simplify 4x minus 2, open bracket, 3x minus y plus 7y, minus 7y. Something like that, all right? And you have to simplify this. Now, like we showed you last week in the example, right? I ensure that I explained that when you're distributing, it has to be the term that immediately precedes the bracket. So it's the minus 2 that you're going to use to go inside the bracket and multiply. We also looked at the fact that there are some students that will make a mistake and say 2 from 4x is 2x, and then distribute the 2x. Be careful of that. Remember, you cannot subtract unlike terms. And you also cannot distribute over a number that is immediately in front of the bracket. So you can't take the 4x and go inside the bracket and then take the minus 2 and go inside the bracket. Those are very, very poor fundamentals, right? Remember, distribution requires an immediate multiplication of the number on the outside of the bracket to multiply whatever is inside the parentheses. So in this case, now we'd bring down the 4x and we distribute the minus 2, which is going to be minus 6x. And then we're going to say the negative times the negative. Remember, the sign outside will affect the sign inside, so that's going to be positive. 2 times y is 2y, and we bring down the minus 7y. All right, and then now we don't have to regroup because everything is already in order. You can see that we have 4x and 6x here. 4x and negative 6x, so that's negative 2x. And then we have 2y minus 7y. We already know that that's going to be minus 5y. I think we're past the stage of 0.5 right now. So I think you guys should be able to figure out that 2 minus 7 is negative 5. All right, and that becomes your final answer. Any questions? Everybody Gucci? All right, assuming that the silence means that everybody's Gucci. All right, lovely. Let's move on then now. Now, you'll be asked at some point, maybe in an advanced question or maybe a simple question, expand the following. Expand and simplify. So sometimes the question will say expand. Sometimes it will say simplify. Sometimes then just let like easy and just make you say you must expand and simplify. All right. Simplification is mandatory. You can't give an expression with more than one of the same terms. So you have to break it down until there's just one of each term inside the expression. So expand and simplify. 3, open bracket, 2 minus x minus 3, sorry, keep using 3, minus 2, open bracket, 3x minus 5y. So I'm trying to do the hardest example so it brings out a lot, right? Hardest meaning I'm doing a question that is quite compact. That doesn't mean that you're going to necessarily get one like this, but the principles is what I'm trying to bring across. All right, so check out this example here. This is going to not only bring out distribution and group-like terms, but it's going to bring out the example that we were discussing last week. And then when we go back to that page there or that section, this is what we're going to be expected to do. This foiling thing that we were doing last week, where we use the first term to multiply the 2 terms on the right, and we use the second term to multiply the 2 terms on the right as well. All right. So the first thing we want to do here is look for any basic brackets to simplify. So right away, I can clearly see that this 3 can go inside this bracket here. But here's where I have a problem now, and here's where a lot of students get themselves in trouble. They'll go ahead and they'll use the 2 to distribute here. And then they might make a mistake. All right, so the mistake that students will make is that they will use the 2 to distribute inside the first bracket, and then they'll make various mistakes. They'll probably write down the second bracket, or they'll use the 2 and then go ahead and do that, and it just causes a bunch of chaos. We don't want that. All right, we're trying to avoid that. So what's my advice to you to make the process of getting to your answer seamless? How do you get to your answer seamlessly without trying too hard? Here's what we do. Once you see a bracket beside a bracket, for example, anytime you see this sort of setup here, we have a bracket beside a bracket, you want to ensure that you expand the double brackets first. And then now, after you expand the double bracket, you use the 2 to distribute. So we're going to go slow for this one. So here, we're going to use the 3 to multiply the 2. We're going to get what? 6. We're going to use the 3 to multiply the negative 5. We're going to get negative 15y. All right. Now, I'm going to bring down back the minus 2. I'm going to wait for the 2. I'm not ready to use it as it. I'm going to bring down the minus 2. And then I'm going to open a very large bracket. This large bracket will contain the expanded terms for the double bracket. Hopefully that makes sense. So I'm going to grab a red marker here now. And look at what I'm going to do. I'm going to use the 3x to multiply this x here. I'm going to use the 3x again to multiply this negative 2y. All right, make sure you catch that. I use the 3x to multiply the x and the 2y, the negative 2y, and then I use the negative 4y to multiply the 2 terms over here. All right, so once I get rid of that double bracket, let's see what happens. So now we're going to go ahead then and we're going to say 6, take away 15y, bring down back the minus 2. Let's go ahead and distribute. 3x times x, 3x squared. 3x times negative 2y is going to give us negative 6xy. All right? And then we're going to move to the second one now. 4y times x, that's going to give us negative 4xy. And then finally now we're going to have what? 4y times 2y, that's going to give us positive 8y squared. So that expression that we have in that large bracket is the expansion of the double brackets. Okay? Now, let's go ahead now. We're going to have 6 minus 15y. We're going to use the minus 2 now. We're going to distribute inside here. Again, I've not really seen a question like this on an exam, but this question is a structured question that brings out the principles of distribution. All right? You don't necessarily have to understand the question. You just have to understand why I'm doing the things I'm doing. Okay? So we're going to proceed now and we're going to go ahead and say minus 2 times 3x squared. That's going to give us minus 6x squared. Minus times minus is going to give us a plus. Remember that this minus sign here will affect this minus sign here. So minus 2 times 6, that's going to give us positive 12xy. Then we're going to have minus 2 times negative 4. That's going to give us positive 8xy. And then you have minus 2 times 8. That's minus 16y squared. Now, if you guys can get to this stage without having to take as much step as I did, fine, not a problem. You don't have to work the maths exactly like me. Some persons can find a way to cut out some of the steps, no problem. But as long as cutting out the steps doesn't cause you to make a mistake, I recommend be more concise. But if you know you're going to make an error or you're afraid of the signs, I recommend that you write stuff down. All right. And finally, now let's look to see if we have any like terms. We do have any constant. Only 6 is there. We do have any terms with only a y. Only 1 is there. We have a term with a square, but this is x and this is y. So that's safe and that's safe. So the only 2 terms that we need to simplify are those 2 right there. So our final answer is going to be 6 minus 15y minus 6x squared. And then we have positive 12 plus 8. That's going to be positive 20 xy minus 16y squared. And if you can see that all of those terms are alike. We have a constant, we have a term with a y, we have a term with an x squared, we have a term with an xy, and we have a term with a y squared. All right? And just to emphasize, ladies and gentlemen, although you say, oh, the answer long, you'll be like, you know, the answer the long, remember that I only designed the question so I could bring out the principles of what we taught. But you're probably going to get a question that is a little less complicated than this one. All right? Okay. Are there any questions? We pretty much use half of the class recapping it. Any questions?
Sir, no question, but you're a bit low on my side. I don't know. Turn up my
Low?
laptop. You're a bit low for me. Yeah.
Are you hearing me now?
Yes, much better.
Okay, all right. My volume was down. My bad. All right, no questions. Everybody good to go. If you're texting in the chat, I can't see it. So. All right, good. So now we can move on to the next phase of our algebraic simplification. Right, we're fast approaching the end of algebra 1. So we have a couple more things to do, right? Because algebra is crucial. Right, I want to at least get to equations before I stop. I know we've been on it for a while, but it's a lot because a lot of the stuff that we're going to be doing in the future will require principles of algebra, which I will not have any time to teach later on. So we want to get rid of them now. All right. So for tonight's class, we're going to be looking at what we refer to as the simplification of algebraic fractions. All right. So algebraic fractions. All right, ladies and gentlemen, finally we're loaded. Let's get to work. All right, so now we're going to be learning how to simplify algebraic fractions. And there's different algebraic fractions that will pop up, different types. All right. So I'm going to be teaching you the fundamental principles behind it. And then we're going to use those principles now to assist us in solving or breaking down these questions. Right. It's a nice 2 to 3 marks question in the exam. If it does come, we want to capitalize on this opportunity here. All right. So algebraic fractions. All right, ladies and gentlemen, without having to give you too much notes, let us just remove the word algebra and go back to week number 2 or 3 when you guys met me. Week 2, number 3, we started to learn about fractions, LCM, cancellation, and all that stuff. We're going to revisit that for a second, right? So for us to understand how to simplify algebraic fractions, we have to go back and recall how it is that we simplify a basic numerical fraction. So here, I'm going to go back to add, subtract, multiply, and divide. So I have 4 questions on screen here. 1. And for each question that I do, I'm going to show you a correlated example that's related to algebra. So let's say we have 1 over 4 plus 2 over 5. How do we simplify that? Anybody can volunteer. I don't want the answer, I want the process. So you're given 1 over 4 plus 2 over 5, and you need to simplify this. What do we do? Step 1.
Step 1, you find the lowest common multiple,
Which is?
which is 20.
Continue.
Then 25 into 4 into 20 goes 5 times. 1 multiplied by 5. 5 into 20 goes 4 times. 2 multiplied by 4. Then you said 5, 1, 5. You write it down there. 4 2 is 8. 8 plus 5. 13 over 20.
Good job. All right, very straightforward. We've been there, done that. That should be very simple for everybody. All right, let's go ahead then and do an example number 2. Remember, we're still doing compressed teaching, so we're cutting out too much of the notes. We want to get to the examples. So let's say you end up with 3 1/4. And let's not use 3 1/4. Let's use 3/5 minus 2/3. All right, let's go ahead. How would you simplify this? Somebody else or the same person, doesn't matter. Come guys, somebody else, man. Jump up, no man. A simple maths, man.
So find the least common multiple, which would be 15. 5 into 15, 3 times. 3 into 15, 5 times. That's 9. Take away 10. And you leave with a negative 1 over 15.
Excellent job. Lovely. All right. So thanks to the student. We are recalling something very basic. All right. Now let's go over here. What do we do when we have a situation like this? 9. Oops. Pardon me. What do we do when we have a situation like 9 over? Let's not do 9. Let's do another one. Let's do 5 over 7 times 21 over 10. What would we do in a situation like this? How would we get the answer to 5 over 7 multiplied by 21 over 10? Same person or different person? Go ahead.
So we cancel.
Yeah. What?
5 into 5, 1. 5 into 10, 2. 7 into 7, 1. 7 into 21, 3.
All right.
So that's 3 over 2. Or 1 and a half.
Or 1 1/2. Very good. So 3 over 2 and or 1 1/2. All right. All right. And then what would you do if you end up with a situation like this then? So say you end up with something like 7 over 9 divided by 7 over 9. Don't like that division sign, doesn't look too wonderful. So 7 over 9 divided by, let's say 14 over 27. What would you do in a situation like this? If you got that to simplify on a multiple choice exam, and you don't have any calculator, what would you do?
So write down 7 over 9 and we flip the other side.
So we'd use the keep, change, flip method, right?
Yes, sir.
Change, flip, not true?
Yep.
All right, the KCF method or the KFC method. And I'm assuming that everybody's in my class, we are familiar with these things that we're doing, right? Because this is fundamentals. So we have 7 over 9. And we're going to change the sign and flip that 27 over 14. And then we go ahead and do what now?
7 into 7, 1. 7 into 14, 2. 9 into 9, 1. 9 into 27, 3.
So our final answer then works out to be, once again,
3
over 2.
over 2 or 1.5.
All right, good. All right. Is there anyone who is unfamiliar with this concept or these concepts? If you are, you need to revisit our earlier tutorial from sometime last semester when we did. If you are, in fact, familiar with it, wonderful. You're on the right path to understanding what we're going to do tonight. Now, everything that my student a while ago just explained, so example 1, example 2, example 3, and example 4, you're going to apply that same principle when you get an algebraic fraction. So if you're adding, you're going to find LCM. If you're subtract, you're going to find LCM. If you're multiplying, you're going to cancel. And if you're doing division, you're going to keep, change, flip. All right? Let's draw a line right here and separate this. Cool. Nice. Let's move up now. Assuming that everybody's good to go with that, let us now apply these same principles now. And we're going to attach on the word algebra to the fraction principle then. So what would happen then if you end up with this situation? Simplify x over 3 plus 3x over 7. Somebody else other than the student who brought us through that whole fundamental reminder. Somebody else want to participate?
So I'm going to try.
Yeah, man, try that. I don't want you to get it right or wrong. You try. Let's go.
So it would be times 4 times 7.
You get 21. Mm-hmm.
And then 3x times.
There's no 3x there.
3 times 3x.
No.
What side there, so?
Plus.
Oh, it would like. Over the 7?
No, but remember what she did in this example over here now. What she did up here, she said 4 into 20 goes 5 times. And then she used the number.
Sorry. Oh, 3 7s are 21, sorry.
Right, so you're going to do that same thing that you did here.
Oh.
So ready again, I'll go on. Tell me what you say I do now.
3. So 3, 7 times x.
One at a time, man. Just tell me. 3 into 21 goes 7. Put the 7 at the top, sir. And then 7 into 21 goes what? 3. That's all? Right?
Yeah.
All right, so 7 times x.
That's it. That's 7.
7x.
7, yeah, 7x.
And 3 times 3x. 3 times 3 is how much?
6.
6x.
3 times 3 is 9.
Oh, sorry. 3.
So 3 times 3x is 9x, right?
Mm-hmm.
And then we go ahead and add those together. 16
16
x over
21.
That's it. So it's the same math you're doing, you know. The x just only make it look like it's a different question, but it's the same math. So the same way how you'd simplify a regular numerical fractions, where you take the denominator, you divide it into the LCM and times it by the top. The same principle is applied when you're adding an algebraic fraction. All right. I appreciate your efforts. Let's do another one. This time we're going to subtract. Number 2. So this is number 1, number 2. Somebody else can choose to participate. If you want to give it another run, no problem. If you want to give it another run to redeem yourself. So 3a over 2 minus a over 7. Somebody else or the same person wants to redeem themselves or get involved? Just stay quiet, ladies and gentlemen. You're putting yourself at risk, Go ahead, listening.
Oh, she's going to do it?
Who is going?
I will try, sir.
All right, go, Stacia.
All right, 2 7 14.
2
into 14 goes 7, so it's 3 times 7.
Well, one at a time. Do the 2 top, yeah. So that's 7 up here.
7.
Next one.
Yeah. And a times 2.
Because 7 into 14 goes 2 times. All right, good. Continue.
3 7 is 21a minus a times 2.
Which is? What's a times 2?
Yes.
What's a times 2?
A times 2?
2a.
Oh,
2a. 2a. Sorry,
but
2a.
just say a times 2. So a times 2 is what? 2a.
Oh, yeah, 2a. Yeah, sorry,
All right.
sorry. So that would be 2 from 21 would be what? 18? That's all?
19.
19a. Yeah, sorry.
Over?
14. Over 14.
You don't need to be sorry, man. It's a part of the process, You're learning it for the first time, So when you make a mistake, that is expected. I don't expect it to be perfect.
Yeah, may I try rigid the A and the yeah, right. So that's the answer. That's the answer.
That says 19a over 14. Somebody was saying something?
no, sir.
All right, you're good then. All right, so number 3. So all we're doing, ladies, as you can see, all we're doing is that we're mimicking the examples that we had that student did earlier. She did all the numerical ones and reminded us of how we did it when we just started or when you just met me, right? And all we're doing now is that we're just mimicking that example or those examples, but this time we're doing it involving letters, right? That's all we're doing. All right. Somebody else or the same person who wants to redeem themselves, I'm gonna try this one. Number 3, I'm going up here. Oops. All right, so what would you do in a situation like 9x to the 4th divided by 5y3 multiplied by 10y5 over 3x7. Now remember, I know that when you guys see some new type of maths, all of a sudden it's like what you did learn not apply. And I said I'm trying to break you guys out of the habit that all of these maths you all learned, they are very much correlated to what we went through. Don't forget that what we went through, we just leave it there. No, that's not how it works. What we went through is still very much applicable. So she just did something with multiplication. If you can go back and just look back at the example, what did she do when she was multiplying? She said something and she used a C word.
Cross multiply. She cross multiply.
Oh, she did not do that. She did something else.
Did it change?
No, she didn't do that either. Look back at the example up here. Look at this example. What did she do when she was doing it? What did she do when she was doing that exam? What was the first thing she did? You guys forget already? No, sir.
So she changed the sign.
She did not do that.
What number can go into?
Exactly. She cancelled. She said
Yeah, she
5 into itself one time and 5 into 10 two. And
right.
7 into itself one time and 7 to 21 3. She only keep change flip when she was down to this question. Pay
The same
attention,
thing,
guys. Pay attention.
same thing would apply to this new
Okay.
one, and they use the same powers, and then you, yeah.
All right. So we're going to go ahead and cancel the numbers now. Start with the numbers then. What can go into what?
All right. So one can go into 5.
1?
Yes,
Yeah,
sir.
what can go into 5 and 10? What can go into 5 and 10?
2 can go into 10.
But it can't go into 5. Let's try something else.
3 can go into 9.
No, look at the 5 and the 10 first. You have to do them one at a time.
Sir,
What can go into 5 and into 10?
5.
Good. So 5 into itself one time and 5 into 10 two.
2 times, right? I think that's what I was trying to say, right? And you keep the powers, right?
All right, we have to do the numbers in first. We're going to deal with the power shortly.
Okay.
So 5 into itself one time. Remember, you're doing the exact thing that remember what she did was that she canceled the numbers. She broke them down. So we're breaking down the numbers first. 5 into itself one time, 5 into 10, 2. Look at the 3 and the 9 now.
All right. So
look at the 3 and the 9. What goes into 3 and what goes into 9?
9, 3 go into 9, sir. 3
The 3 into
times.
itself one time.
Yes, and 3 into 9. 3
and 3
times.
into 9, 3 times.
3
Good.
times.
So we finish with the numbers now, not you?
Yes, sir.
Good. Let's look at the letters now. So here's how you deal with the letters now. Because obviously she didn't do an example with the letters. So how do you deal with the letters now? You start to ask, I'm going to grab a different color marker. Give me a sec. So look at the letters now. Pay attention. It's the blue mark I'm using now. I should just use the green. Let's use the green. All right. So look at what happened now. It's freezing. No. Why do you always choose to freeze at the wrong time? All right, so look at the letters now. Look, watch what's going to happen now. There are 7 X's. Whoa. There are 7 X's down here. Pay attention, guys. Focus. There are 7 X's at the bottom of the fraction. And there's 4 at the top. The 4 at the top is going to cancel 4 of the 7 that's at the bottom. And only 3 X's are going to be left at the bottom. Who catch that? Meds it first before you see you don't understand. There's 4 X's at the top. X time. Oh, hold on. Let me just do this. Let me show you what I go on now. Because you don't have no time to do all of them long something here now. X times X times X times X. 4 X's at the top. Not true? And we're going to divide that by what now? 7 X's at the bottom. X times X times X times X times X times X times X. 1, 2, 3, 4, 5, 6, 7. So look now, look what is happening, guys. This is how I'm getting my answer. This X cancel this X. This X cancel that one. This one cancel that one. And that one cancel that one. So where do you find the remaining X's? At the bottom. And there are 3 X's down there, so we write X cubed. Now we can't do this whole X times X times X, because what if it was X to the 21 and X to the 45? We don't have time for that. We're not going to write down 45 X's and cancel them out. So technically, what we say to ourselves is, we ask how many x's at the top, how many x's at the bottom, and then now based on where the most x's are, our final answer will go wherever the most x's is, or whatever letter they're using. So there's 4 x's at the top of the fraction, and there's 7 at the bottom. The 4 at the top will cancel, and it will also take out 4 of the 7 that's at the bottom. So 3 x's are going to be left at the bottom. Do you understand? Everybody clear?
Yes, sir.
Yes,
I'm
sir.
getting it. Yeah, I
All
get
right.
it.
There's 5 y's at the top, and there's 3 y's at the bottom. This time, the most of the y's in there at the top. So the remaining y's are going to be at the top. So there's 5 at the top and 3 at the bottom. Then what's going to
They're
happen?
gonna have 2 left at
You're
the
going to have
top.
2 left, and it's going to be at the top.
2y. Y to
No,
the
y
second.
squared. Y
Y
squared,
to
not
the
2y.
yes, yes,
Y
yes,
squared.
yes.
So then your final answer now, since numbers are cancelled out and letters are cancelled out, our only task now is to write down back what is left, where you see. So you have this 3 right here, so I have this 2 here, so I'm going to multiply each other. What is 3 times 2?
6.
3, 2, 6.
6. So you're going to leave the y squared there. We're going to put the y squared right here. And then that's going to be over. What's at the bottom? 2 number 1, not 2. So 1 times 1 is 1. And we don't need to write 1 in algebra. So the only thing that's left at the bottom is what? X cubed. And that's your final answer. 6y squared over x cubed. Now you can confirm if your answer is right, and you'll know your answer is right, because there shouldn't, in your final answer, there shouldn't be the same letter at the top that's at the bottom. So when you say everything at the top is different from everything at the bottom, you have arrived at your final answer. But sometimes when you're canceling, you make mistake and forget to cancel out a term. It does happen. It does happen. But you can always know this. For example, what if I was doing this and then end up with x up here? So but I know it's incomplete because I can't have x at the bottom and x at the top. If I'm going to reduce my fraction, I should reduce it to the point where nothing should be able to go into anything. Do you understand? Is it clear? The people them who silent and love talk, I'm going to assume that you are understanding, you know. So if you don't ask no question and not verify, and that is my assumption that the example explained is clear as crystal. Okay. Right? Lovely. Number 4. And I'm taking you to the fundamental examples, guys. Number 4. Now let's say you have a situation like this then. So you have 15 A3 over 8, 15A3 over 8 B2 divided by 3A5 over 2B3. Can somebody participate and tell me how you would process this calculation? What would be your final answer? What would be the process of getting to our final answer? Come, anybody, man, jump up. I need to hear some other voices. It's okay to get it wrong. Not wrong if you get it wrong. We can stay here all night, you know.
Sir, can I try or somebody else wanna
No,
try?
man, somebody else can try, man. Somebody else not come now, guys, man. How are you going to get the bravery if you not try to take on the thing by yourself? We have 23 persons in the class. I'm only hearing 4 voices or 3. Where are the other 20 persons?
Sir, are you going to use the KFC method first?
Yes, go ahead, darling.
So you're gonna keep the first one, then you're gonna change the
Take time with me now. Take time with me. Oh God, keep the first. So tell me if you write down.
so 15A3
Hold on, give me a sec. 15A3.
divided
Over
over 8 2B 8B2
2B or B2.
B2 sorry.
Is
2B3 over 3A5.
Good. Good first start. All right. Good. Next. Not next person. Next steps.
Then they're not going to complete.
You just did it a while ago.
Yeah.
The whole cancellation.
You're gonna
I'm gonna what? I'm not hearing you. I think you're breaking up. We're gonna cancel. Is that what you're saying?
yeah.
Yes, so string to itself one time and string to 15.5, just like we did in the previous example. Remember now the question is a multiplication question, you know. So if you understood this one up here, then this should not be a problem because it's the same question, just different numbers. So string to itself one time and string to 15 what? 5.
Yeah.
Continue.
Then it's gonna be 8 into 2.
8 can't go into 2, other way around.
Sorry, 2 into 8.
Very good. So 20 itself one time and 28 4. Okay, good. All right, now ready for the letters now.
So it's going to go into 3. No, yeah, 3 into the 5.
So how much left? So how much left and where am I going to put the answer?
2A, and it's gonna be at the where the 5 used to be.
Right, very good. So that's A2. Very good. Next one.
Then it's going to be 2 into 3. B.
And where does my answer left? How much B's I have left and where does it go?
You have one more B and it goes where the 3 used to be.
Very good. Good job. Good job. All right. Good job. All right. So now we cancel out everything now. Let's write back what is left now. Pay attention to the green writing now. What's left at the top?
The 5 and the 1.
So 5 times 1 is how much?
1. No, sorry, 5.
5, right? And what else is left up there? Tell me everything we left up there, man.
And then it's
what is left up at the top? The green writing.
The top 1.
Sorry, it's gone. Look at the number, man. Focus. You have to tell me everything that's left at the top. At the top, now the green writing. You see a 5 there, not true? I understand one B.
Yeah. B.
It's a 5 left. No 5B left?
5B.
5B.
And then what is at the bottom now?
4A2.
Right, 4A2. And that's it. Okay? See that? It's just some practicing you need. Yeah, it's just a flow you're not catching. You just need some
It's not 3.
It's not 3?
It's not 4A3.
No, man, we must have 3A up at top, you know. And 5 down at bottom. See, there's 3 at the top and 5 at the bottom.
From before.
2 left. That's so? Yes. Talk to me now. Honestly.
Yes, sir.
So I was interrupting. I was minus in the
But if your minus are still 2, you get
3.
5 minus 3 and 2.
No. I do. Four minus.
Where you see 4? Minus no 4 in that question. Where you see 4 minutes in the 4 now question? Did you write down the question incorrectly?
Wait.
I see a 3 here. I see 1 5. I see 1 2. And I see 1 3. We hear you say the word 4. Where did 4 come from?
Is she referring to the 4?
Bottom part, as in the 4 beside the 8B2.
Yeah, but that's 2 into itself 1 time and 2 into 8, 4. So that 4,
right.
that 4 is right there. I have it there.
Where I go wrong?
Oh, you saw it?
Sir, it's not 2 from the 5.
Where's the 2? At the bottom?
Sir, go back over it, please. Come in now, miss. I took one calculation wrong, but me not see it. Oh, sorry. No, I see it. Don't worry. I see what I did.
I remember erase the whole of the problem.
Sorry. You can still go back over it, sir. I suppose somebody else on the line don't understand it.
All right. Right.
Minus 2 left 3. Oh, get that the 5 from.
You must your mic is unmuted here. All right. Let's run back through that again. So what we're struggling with now, ladies and gentlemen, what we're struggling with here is the transition of working numerical fractions to algebraic fractions. Remember, the principle is still the same, you know. We can't say no. So again, as the young lady said, we're going to keep change flip. So we're going to keep the first. So we're going to keep the first. I don't know why my device chooses to be freezing at this point in the class. So we're going to keep the first, 15. Pay attention, guys. We're going to keep the first part of the fraction. We're going to change the sign. And we're going to flip the last. No, cancel out. No, remember, a multiplier and multiplier. Cancel out. If you understand number 1, then if you understand number 3, as you said, if you understand number 3, then number 4 is the same question. With number 4, the only thing I did extra was that I change, and I flip. That's it. Now cancel. 3 into itself, 1 time. 3 into 15, 5. 2 into itself, 1 time. 2 into 8, 4. Let us know, pay attention. There is 3 A's at the top and 5 A down at the bottom. So when this 3 A up at the top, cancel out 3 of the A's that are at the bottom, 2 extra A are left down there. So catch it? And when you have 3 B's at the top and only 2 at the bottom, the 2 at the bottom disappear, and 2 of the 3 that's at the top, leaving only 1 B at the top. So your final answer is going to be what's written in red. The answer is going to be what's written in red. So 5 times B, 5B, because 5 times 1 are 5. So you don't need to say 5 times 1 times B. 5 times 1 is 5 along with the B. And at the bottom then we end up with the 4. I want to say this number 1. So 4 times 1 are 4, pretty much. If there was another number, we'd say 4 times 2 or 4 times 3, whatever the case is. So in this case, 4 times 1 is 4 along with the A squared. And your answer is correct because there is no A at the top and there's no B at the bottom. Is it clear? Is it clear?
Yeah. So far. I think
But
I
now,
was
you know,
multiplying, that's why. You know what? I need a minus 2 from 5.
you mean you're doing them at the bottom, but those are 2 different letters.
Yeah.
You cancel numerator with denominator. You never cancel numerator with numerator or denominator with denominator. That's why we did the example all the way up here. That's why I did these examples first, because you notice that at no point I didn't try to say 7 to 10.
Yeah.
All the way can't. I canceled crossway. All right. So that was the purpose of those examples at the top, to create a correlation between the numeric calculation and the algebraic ones. All right, we're going to turn up the heat a little. We run out of time still, but it's a part of the process. That's how it go. I'd rather you get the fundamentals and then later on we kind of beat up with chest about the advanced ones. All right, so look at these. So simplify. Three x minus 2 over 4 plus 4x minus 7 over 5. All right, that's one example. And let us do another one. Let's do 3 over 2x minus 3 minus 4 no. So 2x minus 3 so 2x minus 3 over 4 minus 5 over x minus 2. These are some more challenging ones, right? We're going to go a little bit over time because these questions will take a little bit more, right? So these are some more challenging examples, right? But the principle remains the same. Principle remains the same. All right. All right. Focus, everybody. Focus. Number 1. What's the rule for adding and subtracting fractions? Regardless of what kind of fractions. Once you add and subtract, what are you required to first do?
LCM, sir. 4 5 20.
Not change, right? Exactly, not change. Same principle. So LCM is what? 20. So we're going to apply the same principle as we were doing earlier. What is 4 into 20?
5 times.
You put down the 5 on the line and you open the bracket. You open the bracket and you bring down what is at the top on the line. You should say catch that, So when I say 4 into 20, I'm write down the answer for 4 into 20 on the line. And then whatever expression is at the top, I'm going to bring it down on the line. What is 5 into 20?
4 times, sir.
Put on the 4 on the line, and whatever is at the top,
Bracket.
I'll bring it on the line. Everybody catch that part there? Everybody catch that part before we move on?
Yes, sir.
Yes, sir.
All right, good then. Now, look at what is on the line. What is on the line is a reflection of what we did last class. So we have this term outside to multiply what is on the inside. So you see the importance of last week's class. If you never understand last week's class or you miss last week's class, then what I'm doing now is going to feel a little bit uncomfortable. But we'll go through this. We'll go through several examples of this last week. So 5 times 3x is what? 15x. 5 times negative 2 is negative 10. Plus 4 times 4x is 16x. And 4 times negative 7 is negative 28. I'm going to put all of that back over 20. So, everybody good this up?
Yes, sir. Then you do the like terms.
All right, and just like we were doing. So all you're doing now, guys, as much as all the maths look different, all you're doing now is that you're fundamentally putting all the pieces of the puzzles that you got from the last class. The distribution, the group-like terms, what to add to what. So we know so we cannot take 10 from 15 if there's anybody in here with 10 about 5x, you see. We don't establish that from the very inception of algebra that you cannot subtract terms that do not look exactly the same. So hope nobody in here go write down 5x. We're going to say 15x plus 16x minus 10 minus 28. I'll put that all back over 20. Now, I know that some of you guys may be in here and saying that, sir, do I have to write that third line or that fourth line? No, if you know, say 15 plus 16 is 31, go ahead and just go ahead and do that. But I would recommend that you do it because, like I said, there can be some science problems that lie underneath your fundamental mathematics. Some of you guys are still using owing and have. At this stage, you shouldn't be, but if that make you comfortable, cool. 15 plus 16 is what? 31x. All right, interesting. What is minus 10 minus 28? Oh, I'm going to take so long to tell me the answer.
Minus 38.
Yeah, you're not supposed to tell me that within split seconds. Minus 38. Within 2 seconds, I should hear somebody spit out the answer over 20. And that's your final answer. The answer is 31x minus 38 over 20. Cannot go any further than that. Is it clear? Is it clear? Any questions from anybody? Or no good?
Good.
Good then. Moving right along. All right, again, we are subtracting fractions. So not change, it's the same principle. Now, with this one now, tricky for some people. Because unlike the previous example, we always seem to have numerical values at the bottom. But with this one now, we have a numerical value, which is the 4. But we end up with this weird looking expression here at the bottom, which you're not accustomed to. So how do you deal with a situation where we have a number and an expression? Whenever you can't seem to multiply, right? Whenever you multiply and you can't seem to get a numerical value, rather than multiplying it, what you're going to do is that you're going to put them beside each other. And that's going to be your LCM. You're going to put them beside each other. Please make a note of that if you forget. If you end up with a numerical value at the bottom, along with an algebraic expression at the bottom, do not multiply them and get some weird looking expression like 4x minus 8. No, just write them down at the bottom beside each other. Everybody clear on that?
Yes, sir.
Cool. Next, we're going to do the same procedure now, not change. This time now we have to be a little bit manipulative. So we have to know of find a way of interpret what it's asking us. Now, look at this now, ladies and gentlemen. Focus now. You see that 4 here, right? So look, let me get one cursor. I wish I had a cursor. All right, so you see this 4 right here, so? And I try to get a cursor. Hold on. Trying to get a cursor, guys. All right, let me see if we can get a cursor. You see this 4 right here? Sorry, guys. You see this 4 right here, so? Look, pay attention. You see this 4?
Yes, sir.
This 4 right here, so. This 4 is going to cancel this 4. And what is it going to leave you with? If this 4 cancel this 4, what is left?
1.
No, come again. Look at the bottom.
4 into
Look at the
4.
bottom. If this a 4, if this 4 cancel out this 4 and cross it out, what is left?
What's x minus 2?
Yeah, that left. Now hit the down at bottom. If at the bottom you have, pay attention now, guys. If at the bottom you have 4 and you have x minus 2, I'm just ask you, say, if this 4 cross out this 4, what's going to be left?
X minus 2.
And that left down there, nothing else not down there. You can't say 4 into 4. 4 into 4 goes one time, but that's how we say cancel. So 4 cross out 4, and I'm going to leave you with the x minus 2. And remember that we said that what is at the bottom is going to come down on the line. Do we agree? That's what we did earlier, right? When we get the answer, we brought down what was at the top, and we brought it back on the line. So the same thing here. Come again, let me run that. Watch the cursor. Watch the cursor. The question I ask is, so the question I asked you was, I'm trying to get my cursor, but the screen keeps freezing. So I asked the question. Not working out. I'm trying to get the cursor, but it's not. It's freezing. All right, so see it here now. So come again now. Question I asked you was what? Look at my cursor. If this 4 cancel, means say cross out. If this 4 cross out this 4, what's left? X minus 2. So we put the x minus 2 on the line, and then what is at the top? We'll bring it down on the line. Let us see. That's the same thing that we did over here. 4 into 20. 4 into 20, 5 times. We put the 5 on the line, and whatever was at the top, we'll bring it down on the line. And the same thing we do over here. 4 into this goes x minus 2. Therefore, we'll put the x minus 2 on the line, which is my answer, and I'll bring what is at the top on the line. Is it clear?
Yes, sir.
You think take practice, you know? It'll come overnight. All right, now I'm going to grab another cursor now. Pay attention. This x minus 2 now, listen guys, at the English now, you know. This x minus 2, this x minus 2 here, so it cancel out this x minus 2. What is left?
4.
Correct. 4. Very good. So we're going to bring down the minus 4, because the minus sign comes down, and we're going to put the 4 here, so. And then whatever is at the line, whatever is at the top of the expression, we're going to bring it down on the line. So we end up with 4 times 5. Are there any questions? I love my class not interactive, you know. And it's not talking to the chat and I don't know. All right. Now, can somebody tell me what do I do next? See, me have two double brackets there, so apply what you learn now, you know. So you can't say, sir, me stuck. You can't stop because we just went through this practical example. I would say anytime we see one double bracket, we must do something. What must we do? If we go back up to here, so when we were doing the revision, what did you do anytime we have a double bracket? We use the foiling method. So you see that little foil method there? So now it's been applied. Because remember, it now will come like that. It will pop up in the middle of some questions. So, anybody wants to foil this for me? Nobody wants to help me? Okay. X
Yes,
times
sir.
2x.
X times 2x. And
then
x
that.
times minus 3. Take it on.
Times 2x and the minus 3.
So what is x times 2x?
Two x squared.
Very good. What is x times 3?
3x.
Very good. What is negative 2 times 2x?
Negative 4x.
Very good.
And
what is negative 2 times
6.
negative 3?
Positive 6.
All right. And what is 4 times 5?
That's a minus 20.
And we're going to put everything back over what? 4.
4.
Open bracket.
Open bracket x minus 2.
All right. Good. Now, what are the terms that are alike? Tell me one we can add to each other. What and what look exactly like? Yeah.
The 3x, minus 3x and minus 4x.
Which is a total of what?
Minus 7x.
Very good. Got your O3.
And 6 from 20, leave 14. Minus 14.
Minus 14. Now use no 1.5 again. We passed that stage. We've been at this game for 3.5 months. By now, we're supposed to get this 1.5 business. By now. Minus 3 minus 4 is minus 7. 6 minus 20 is negative 14. And your final answer is going to be 2x squared minus 7x minus 14 over 4 open bracket x minus 2. All right? So all of these are just class examples, really. And I'm showed you already. And I'm going to show you again. If you're one of those type of students who always feel like they need to practice, there's nothing you cannot do. Everything that you want to do is on the internet. You can go on your Google, right? Oh, did you guys get that? Oh, as a matter of fact, let us use the time. Did you guys get a chance to see what the 2026 January paper looks like? Did anybody see it?
Sir.
Anybody in here see it?
Yeah.
No, sir.
Oh, you not see it?
Yeah, I saw it.
It's supposed to be here.
Curry, Springer, and Terry, they were working it out.
Okay. It will be very interesting for you guys to go ahead and start, fool around with that document, see what the paper looks like. It gives you it make you kind of see which part you're there. Because some of you guys don't really like to face the reality, The class here is just to guide you. My job is just to guide you and give you examples of what can come. But the application process is going to come through experience, through practicing. Okay? I'm not seeing it here. But anyways, you can just go here and you can type in chat GPT. Show you, or you can find the questions and practice on your own. You can go here, chat GPT ask you, what can I help you with? Can you prepare? You can prompt it how you want to prompt it. Can you prepare 10? You know what I want 10. 10 Csec algebraic. Oh, cannot spell algebraic. Can you prepare 10 Csec algebraic fraction questions from the Csec mass curriculum. You want to prompt it properly. So what ChatGPT will do is that ChatGPT the AI will go ahead and check out every possible paper that CXC has ever come up with algebraic fractions. So can you prepare me 10 CXC algebraic fraction questions from the CSET math curriculum and then prompt it to do? Wait a second, sign up for free. Nobody said no. Log in. Oh, hold on, give me a sec. I'm going to sign up with my Apple, right? All right. And so the ChatGPT. Hi, what is going on? And I don't look for my birthday. Because I'm not going to see me for my birthday. I should ask me again because I have to sign in. School. Skip all of that. We can't bother. Skip tour. All right, ready again. So can you prepare 10 CSEC algebraic fractions questions from the CSEC math past paper? You can prompt it specifically to give you some questions from the past papers. From past papers. Past papers. All right, and you prompt it, and then it's going to search the web, and then it's going to come up with some algebraic fractions. Look at those. So some basic little ones, right? I don't really like these ones anyway. You're going to need some expression. So it only give you some. So you have to write a proper prompt for it because it's going to just prompt you. It's going to give you some random questions. Like look at number one. So number one looks just like the first example we did in class. But then as you reach the number two, you start to see some factorization questions, which I haven't taught you as yet. Right? You haven't seen the factor. So look at number 5. You can do number 5. You can do number 6. You can do number 7. You can do number 8. You can do number 9. And number 10 is a little bit challenging. So there are questions, but you have to write a proper prompt for it to give you specifically what you want. All right? So you have to use up your resources then, ladies and gentlemen, okay? All right, so that is it for this class. So I'll see you guys on Thursday. We will pick up from where we left off. And until then, take care. Have a good night.
Good night, sir.
Nice.
Night, sir.